there are 5 main periodic properties that we're going to look at, and these actually should all be a review of your prep class. Okay, so we're going to look at atomic size, let's try rewriting that. Okay, effective nuclear charge. Ionization energy. Electron affinity. And metallic character. Okay, and I have split each one of these up into their own little sub-video. So we're just going to look at atomic size here. All right, so atomic size. Well, how do we measure atomic size? We look at our atomic size by basically, what is the distance from the nucleus out to the outer portion of it. We can use those nucleus to nucleus distances to help us figure out the size of bonds as well. Okay? So when I look at my atomic size, I see this general trend that as I go across the periodic table, my atomic size gets smaller. Then when I go to the new energy level, my atomic size jumps up, and then it gets smaller, and it jumps up, and it gets smaller. Okay? I see some bouncing around in there in the transition elements. Now here's the thing, the transition elements kind of have their own little thing going on because of all those d electrons. If you take second semester general chemistry, you will cover a significant chunk with transition metals. So we're mostly considering the trends that we see in our main group elements here. All right, so generally speaking, we see that, as we go across, our atomic size gets smaller. Okay, so here's that trend. So as atomic size gets smaller, what else is getting bigger? That's the effective. So the trend here is atomic size goes down, Z effective goes up. So what happens? Well, if I have a larger Z effective, because if I'm in the same energy level, all right, I'm crowding more electrons into the same sublevel. But every time I go from one element to the next, I not only have increased the number of electrons, but I've increased the number of protons. And so if I'm crowding more and more into the same shell, but I'm also increasing that positive charge, we're going to get a constriction there because we feel more charge. And so the more charge we feel, the more we're pulled. And so we get smaller. Okay, so we get more pulling of Li electrons. So we get that smaller size. All right. And so you can see here that as I go across, I get smaller. As I go down, I get bigger because once I go down in energy level now, I've jumped out to a new energy level, so I've gotten bigger. And once again, our transition elements, they show a lot of exception to the general trends, so we're not going to consider them as much, but I have thrown in here, you can see that I've got that blue call out there for the transition element. So you can see that we do get a little bit of that constriction going on, but we get a lot of kind of stability in that size because we're dealing with the 3D or the 4D or the 5D electrons as we continue to fill through our transition metals. Now, when I make ions, okay, my cations, my radius is going to decrease due to an increase in the Z effective. My anions, my radius is going to increase due to a crowding of more electrons in the shell. So radius decreases due to an increase in effective nuclear charge, and then radius increases due to crowding of more electrons into shell. Okay, And so what does that look like? Okay, so my sodium goes from 186 picometers all the way down to 102 picometers because now I've removed an electron, and the electron I removed was from the energy level 3, and now I'm down to energy level 2. So you can see here, in gray is my ground state, and in maroon is my ion, and you can see how significantly smaller all of the cations get. Okay, and then my anions in gray is my ground state, and turquoise is my ion, and you can see how significantly bigger all of my ions get. And then I just like this, I think this is kind of interesting, that when I look at this, my sodium ion and my chloride ion almost change places. So sodium goes from 186 nanometers to 0.095 nanometers, whereas chlorine goes from 0.099 all the way up to 0.181. And so they kind of almost swap sizes there. And so sodium goes down when a cation forms, chlorine goes up when the chloride anion forms.